Hello everyone, today we're doing lesson 6.4 and it's entitled Nth Roots. And yes, nth is a real term. It's a real thing. Okay, so this lesson is all going to be about roots. So what we have here is called the radical symbol. So anytime that symbol is used, we think of it as a root, but the symbol itself is called a radical, just like, this is the plus sign. So it has a name, it's the radical symbol. Now, radical symbols all have an index. The index is a small number written in sort of the crook of that notch there on the radical symbol. So, for example, this is a third root, or it might be called a cube root. This one with an index of 4 is a fourth root. You can have a fifth root, sixth root, whatever. Now, when there is no index, but it's still being used in a mathematical equation, expression, or whatever, it's assumed that there is a 2 as an index. It's never actually written, but when you just have the radical symbol with no visible index, you just assume that's going to be a square root. And you've already covered square roots over and over. If you put an n here, that's called an nth root. And that's just a way to express the general idea of a root with any particular index. So an nth root, you can have a 7th root, an 8th root, a 12th root, an nth root, whatever. That's really not that important, but just try to make you understand the vocabulary that is going to be thrown around here. So what we're going to do, we're going to spend a short time to learn how to do various roots on a calculator. You should already know how to do a square root, and maybe you know how to do a cube root. Some calculators have a cube root button. But what if you have to do a 7th root or a 5th root? So we're going to talk about that. It's not going to take a very long time. Then we're going to learn how to simplify roots, including variables with a calculator. In fact, I should say learn how to simplify nth roots, because we have already learned how to simplify square roots. We've done a lesson on that without a calculator. So if you had like the square root of 96, we talked about how you make a factor tree, 2 and 48, and 2 and 24, and that's 2 and 12, and that's 2 and 6, and that's 2 and 3. And with a square root, you're looking for pairs of numbers to simplify. So we have 2 squared, we have another pair of numbers, which is 2 squared again, and then there's an extra 2 and an extra 3. And so what happens is the square root cancels out the square. They are opposites, and you're able to simplify out this 2, and then you can simplify out that 2 because those squares cancel. And then the other 2 and the 3 are left inside the radical symbol. Sorry, that 2 doesn't really look like a 2. And then 2 times 2 is 4 out here, 6 in there. So the square root of 96 is what we started with, simplifies to 4 radical 6. And we've done a whole lesson on this. We had a quiz on it, had a test on it. Hopefully you recall this is something that you know. We're going to be doing that idea in the long run, but we're really going to be expanding on it, involving higher roots and variables. Okay, but first, let's do what I said we were going to do first, and that is use a calculator to evaluate each square root, and we're going to round to the nearest thousandth. In case you forget, so the way place values work, there's the ones place, then you put a decimal, and there's tenths, hundredths, thousandths. It goes on 10 thousandths, 100 thousandths, etc. It gets to be a tongue twister. Anyway, a thousandth is a third decimal place, so we're going to be rounding off to the third decimal place. Let me pull up the calculator, and whether you're using Desmos or some other calculator, they pretty much all have a square root button. Square root of 22, 4.69, and then the next number is a 0, and the next number after that is a 4, which means we do not round up. We're going to keep that 0 a 0. So just because I always like to check, there it is. You don't even need the 0 on the end of that. Although you can write it, it's okay. But now a cube root. If you look on the Desmos screen, there is no cube root button. So you go to the function menu, miscellaneous, and there you see the nth root button. Now when you press it, it doesn't put an nth root on the screen. You've got a blinking cursor there where the index goes. That's where you put your 3. Then you move the cursor down underneath the radical, and that's where you type in your 37, and you end up with 3.332. So the answer number 4 should be 3.332. 4.1 2.55. That can't possibly be right. Okay, I admit I made this answer key, and I think I accidentally did the square root of 37. No? Why is that so wrong? Cube root of 37, 3.332. All right, I don't know where I got that from. Tell you what, if any of the rest of the answer key is wrong as you're doing this, I did these by hand, so yeah, you might have to deal with some inaccuracy there. Let me know. Give me a shout if I screwed up on any others. Let's do number 6. So fourth root. So again, function, miscellaneous is already highlighted. There, the middle column right there is the nth root button. Type a 4 there and 125 down there, and I get 3.344. Now that's 3437. The 7, since it's 5 or bigger, rounds up. So you round that 3 up into a 4. Let me see if I did this one right when I made the answer key. Oh, right, finally. Okay, so I don't know what happened there. Definitely it was my mistake. Hopefully we move on. Don't hold that against me. I promise not to hold your next mistake against you. Okay, now what did I do? I got rid of the calculator. Yes, you're going to use a calculator on 1, 3, and 5. But from here on out, it's simplify. So number 7 and 8 are kind of a review, a throwback to what I did here. And for that, I'm going to use the factor tree. So 72 is 2 times 36. 36 is 2 times 18. That's 2 times 9, and that's 3 times 3. Looks like I got a pair of 2's here, so that's 2 squared. I have a pair of 3's here, that's 3 squared, and then an extra 2. So put that all underneath the square root bar. The ones with squares are the ones that simplify. The square root cancels a square, you can bring out a 2. Cancels that square, you can bring out a 3. And radical 2 is left behind, so this becomes 6 radical 2 is a final answer, or 6 square root of 2. Check number 8. 6 square root of 2 it is. Now, no, where am I? There we go. Number 10. It's going to be a little more complicated, or it's not more complicated to be honest, it's just different, but it's a cube root or a third root. We're still going to make that factor tree. 2 times 16, 2 times 8, 2 times 4, 2 times 2. Now with a square root, you look for pairs of numbers. With a cube root, you don't want to find pairs of numbers. That's not good enough. You want to find 3 of a kind. So play poker or play Yahtzee. 3 of a kind is what we're looking for with a cube root. So what do we have? We have 3 2's. That's 2 to the third power. Then we have an extra 2 and another extra 2. And we're doing the cube root of that. So now the cube root is going to cancel out the third power, and we can bring out the 2. What's left in here, 2 squared, or if you wanted to, you could write that 2 times 2. Whichever way you have it, that's going to make 4. And so we end up with a final answer of 2 cube root of 4. And that should be all there is to that. Let's check number 10. Yep, 2 cube root of 4. Now I almost made a dumb mistake, I won't lie. I had originally wrote that down, and I'm like, but wait a second, the square root of 4 is 2. Why didn't I do the square root of 4? Because it's not a square root. I forgot to put the index here, and I fooled myself into thinking it was a square root for just about a split second. I mean, I don't know if you saw me stagger for a second there when I was working this one out, but yeah, so that's the answer. The cube root cancels out, where am I? The third power right here. So this 2 comes out. These 2 2's from down here stay inside, and that's where that answer comes from. All right, number 12. So since the index is 4, when I do my factor tree, I'm going to hopefully find 4 of the same number. Now, 405 is not a small number. I mean, it's kind of hard to work with, but it ends in 5. You know that any number that ends in 5 can be divided by 5. So that's going to be 5 times, okay, what? 40 divided by 5 is 8. 5 divided by 5 is 1, so that's 81. You know 81 is 9 times 9, so this is 3 times 3. And this one is also 3 times 3. So look, we've got 4 3's, that's 3 to the 4th power, and then a 5. And we're supposed to do the 4th root of that. The 4th root and the 4th power, They cancel out, so I can simplify the 3. The 5 does not simplify because there's not a fourth power there to cancel out. So that 5 is going to stay inside. And that should be it. Nope, I got to put the little 4 in there, put the index in there, sorry, for the final answer. I hit my microphone. I hope that didn't make too much noise. There it is, 3 fourth root of 5. 3 times the fourth root of 5. So this process is basically the same process that we learned how to do in a previous lesson. It's just we only did square roots before, so you only looked for pairs of numbers. When you do a cube root, you look for 3 of the same number. Like I said, 3 of a kind. If you have a fourth root, you're looking for 4 of the same number, 4 of a kind. Now let's move to number 14. From this point on, we've got both numbers and variables. Now, different teachers teach this different ways. I like to split them up into the number and the variable. It doesn't have to be done this way. And when you get into doing this yourself, if you find out you can work these out without splitting them up, fine. But I like to do the number as like a separate problem all by itself. So 108, it's an even number, so I can divide it by 2. That's going to be what, 54. That's going to be 2 times 27. 27 is 3 times 9, and that's 3 times 3. So I have a pair of 2's, a pair of 3's, and then an extra 3. So let me go over here. So I got the square root of 2 squared, 3 squared, and an extra 3. And then x to the 4th, well, that's x times x times x times x. I mean, that's what 4x's mean, right? So you got a pair of x's here and a pair of x's here. Now, that's a weird way to make a tree. I mean, you could have done, it's x times x to the 3rd, and then that's x times x to the 2nd, and that's x, times x. And now here I have, what am I doing? A pair of x's and another pair of x's. So if I want to make it look like a factor tree, I can do it that way, but usually you don't have to do that. You can just say, oh, x to the 4th, that's 4 x's. And then you pair them up. Here's a pair, there's a pair. So I got x squared, x squared. All right, so anyway, we're doing a square root, so all the ones with squares are going to simplify. I can bring out a 2, a 3, an x, and another x. And then, let me switch colors here, that 3 is just going to stay underneath the radical bar. So if I finish this off, 2 times 3 is 6, x times x is x squared, radical 3. So this is sort of a step-by-step way to break it down and do it and make sure you get the right answer. There certainly are shortcuts. There's ways that you can do, instead of splitting it into 2 and working out, you can do it all at the same time. And I'm just going to stick with this method to be as consistent as I can. All right, let's look at number 16. It is another square root. So square root of 50, square root of a cubed. What? That's an a. Where did I get 3 from? A cubed b to the 4th. So 50 is 2 times 25, and that's 5 times 5. So I got a pair of 5's and a 2. So let me go over here. 5 squared, and then a 2. For the variable, basically I've got 3 a's. Wait, I don't need that. 3 a's, 4 b's. So I got a pair of a's, and then an extra a pair of b's, and another pair of b's. I hope that makes sense to you how I'm doing that. So basically, I know that a square root cancels out a square, so when I break these down, I'm looking for pairs of numbers. A pair of 5's, pair of a's, this is getting sloppy, a pair of b's, and another pair of b's. So now what? Well, everything with a square is going to simplify out. I can bring out a 5 right there, an a from right there, a b from right there, and another b from right there. What stays behind? Well, I've got the 2 stays behind, and that a. So if I clean this up, my final answer is going to be 5a b squared radical 2a. These I can put back together as b squared. Now, are there shortcuts? Are there different ways to do this? Yes. I'm not going to get into it. Sometimes shortcuts help tremendously. Sometimes when the teacher teaches a shortcut, half the class gets really thrown off and confused by it, and I'm not going to risk that right now. Okay, number 18. Now, this one has a negative, and we've talked about the importance of negatives and roots before, but really we've only talked about the square root of negatives. Remember, if you square root a negative, like -1, you get the imaginary number, okay? That's a thing, that's important. This paper is not going to have any square roots of negatives. It's just not going to happen. But we do have a cube root of a negative. So the question is that imaginary? So I'm going to deviate from this problem for just a minute, bear with me, and I want to look at the cube root of -1. Okay, so I'm taking a much easier number, -1, much easier than -375. So a cube root means we've got a number times itself times itself. The reason you can't square root -1 is because if you ever try to multiply two negatives, you get a positive, which that doesn't work, and two positives equals a positive. And if you were to try to do one positive and one negative, that does give you a negative, but a square root is supposed to be the same number by itself, and those aren't the same number, they're different numbers. That's why you cannot square root a -1. But with square root of -3, you can do -1 times -1 times -1, right? When you multiply two negatives, they turn positive, but then multiply that by a third negative, and it stays negative. So, what am I driving at here? You cannot square root a negative number unless you start involving imaginary numbers, which we're not doing. You can cube root a negative number. And as it turns out, you cannot fourth root a negative number because that would require 4 negatives, which equals a positive. But you can fifth root a negative. So as long as the root is as long as the index is odd, it's fair game. You can do that. But as soon as the index is even, you start getting in the world of of imaginary numbers. And like I said, that's just not going to happen on this paper. So the takeaway is, if you're trying to do an odd root of a negative number, it's just going to give you a negative answer. It's that simple. When you odd root a negative number, you get a negative answer, period. Then you can just do the rest like I had done every other problem. Okay? So, 375. Well, it ends in a 5, so I can divide it by 5. That's going to be 5 times 75. 5 times 75 is 375. 75 is 5 times 15, and 15 is 5 times 3. Yeah, that works. So we've got 3 5s. That's 5 to the third power. An extra 3, that's just 3. Now for the variable, well, this is almost counterproductive. It's m times m times m, and there's 3 of them, which is m cubed. So in this problem, I could have just copied that up there. I mean, if the power in the index match already, you don't really have to break it down. So what does that give us? Well, we've got our negative sign there. The ones with the odd powers are going to simplify. So I can bring out a 5, and I can bring out an m, and the 3 stays inside. And remember, that was a third root, so I needed to have a little 3 there for my index. That should be the final answer to number 18. Let me check. -5m cube root of 3. Where am I? What did I do? Did I skip ahead? Right there. Okay, I didn't check my last couple problems, did I? So, bad. My bad. 14 should be 6x squared radical 3. 6x squared radical 3, right? 16 is 5ab squared radical 2a. 5ab squared. Okay, I wrote 5ab squared radical 2a. They inverted those. It doesn't matter. It's the same thing. So same answer, right answer. We're good. And then 18, yeah, I just checked. Okay, number 20. Again, another cube root. So let's look at the numerical part. 448. Well, they're even numbers, so I can divide by 2. That's going to be 224. 224 is even. That's going to be 112. 112 is even. That's going to be 50. 112 divided by 2, 56. And by the way, if you don't do the mental math so well, just have your calculator handy, have your phone handy, split the screen and bring Desmos up off to the side, whatever. You know, just make it easy on yourself. 56 is even. You can divide that by 2. That's 28. That's 2 times 14, and that's 2 times 7. So we're doing a cube root. We're looking for 3 of a kind. There's 3 2's there, 3 2's there, and then an extra 7. So we got cube root of 2 cubed, another 2 cubed, and then a 7. Now for the variables. Cube root of m to the 4th, n to the 4th. Well, that's 4 m's. I almost started writing the number 4. M, and 4 n's. N, 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 n. Again, we're looking for 3 of a kind here, so that's m cubed with an extra m, and then n cubed with an extra n. So if I want to simplify this, hold on, let me try to make this a little neater. I think that's my biggest challenge here, is keeping things lined up and clean. All right, so the cube root is going to cancel all of these things with a third power. So cancels that, I bring out a 2. Cancels that, I bring out another 2. Cancels that, I can bring out an m, and that one I can bring out an n. And then I'm going to have what left behind? 7, and then that m, and then that n. And then finally, you can clean it up a little bit. 2 times 2 is 4. So 4 mn cube root, I forgot my 3 there, of 7mn. That looks like a fairly complex answer. Let's hope it's right. Number 20. If it's not right, I'm going to stop the video, delete it, and start over. There it is. 4mn cube root 7mn. So this is just simplifying. We're learning how to work with different types of roots. Let's go with 22. So we're doing the 4th root of 162. I love even numbers because I know I can start my factor tree out with a 2. 16 divided by 2 is 8. 2 divided by 2 is 1, 81. 81 is 9 times 9. And these are 3 times 3 and 3 times 3. So it's a 4th root. We want to find 4 of a kind. There's 4 3's right there. So 4th root of 3 to the 4th power. And then there's that extra 2. Now for the variables. 4th root of x squared y to the 6th. Okay, x squared, I mean, you can break it down into x times x, but there's not 4 of them, so it's almost pointless to do that. Y, since this power is higher than that power, this one will be worth the effort. 1, 2, 3, 4, 5, 6 y's there. We're looking for 4 of a kind, so there's going to be y to the 4th, and then there's these 2 x's, which I'm just going to go ahead and make that x squared, and 2 y's, which I'll make y squared. So what does that give me? Okay, the ones with the 4th power I can simplify out. So I bring out a 3, bring out a y. What's left behind is the 2, the x squared, and the y squared. And that should be the answer to 22. And I've actually forgotten. So 3y, 2x squared, y squared. 3y, 2x squared, y squared. Right, that's it. Okay. Wow. My short-term memory is so bad. Between here and down there, I lose track of what I'm doing. That's wonderful. Okay, so they're all pretty much like this. Well, look, 26 is different. I was going to say you could stop the video and get to work, but if you want to see how I do 26 because it looks different, hang in there or fast forward ahead. But first, number 24. So we're doing a cube root. We're going to look for groups of 3. I'm going to start with 216. That's going to be 2 times 108. And half of 100 is 50, so that's 2 times 54. 2 times 27, right? Half of 54, yep. 7 is 3 times 9, and 9 is 3 times 3. So again, with a cube root, we're looking for 3 of a kind. So there's 3 2's and 3 3's. How about that? That's different. So we got the cube root, 2 cubed, 3 cubed. Now for the variables. Cube root of x to the 7th. All right, that's not going to give me a lot of room to work here. 1, 2, 3, 4, 5, 6, 7 x's. And 4 y's. 1, 2, 3, 4. Now I'm looking for groups of 3. Again, cube root. Here's 3 x's. Here's another 3 x's. So I've got x cubed and another x cubed, and then 1 leftover x. And then for the y's, I do have a group of 3 y's and 1 leftover y. So now to simplify this, since it's a cube root, everything with a cube is going to simplify. So everything in yellow, I bring out a 2, a 3, an x, another x, and a y, and I've just run myself out of room. Hold on. Shrink that down, move it over. And then this x and this y are left inside there. So I can make this 6, right? 2 times 3 is 6. X squared, x times x, y times the third root or cube root of xy. All right, let's lock that into the short-term memory. 6x squared y cube root xy. 6x squared y cube root xy. Got it. Hey guys, we're almost done. The last problem is actually not as bad as it looks. If you see something like this on paper in a math class, you might think, oh great, now I got to do this and I hate this. It's the FOIL and it's all this writing and all this. No, you don't have to do that. This is like the simplest paper or simplest problem on the whole paper. You have a square root, you have a square. What do square roots and squares do to each other? If you said they cancel each other out, you are right. And the answer is 2a plus b, and you're done. That's all there is to this problem. No making a tree, no foiling stuff out. That's it. The square and the square root cancel each other out. And so you get that. Not to beat a dead horse, but if it was like the 5th root of 2x plus 5y minus 7z to the 5th power, well, you would just cancel the root and the power, and that would be your answer. Okay, I'm going to end it here. If you have any questions or concerns, please contact me through email or through comments in the Google Classroom, and I will answer you as quickly as I'm able to. Otherwise, good luck and have a great rest of the day.